Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And we are actually seeing the optical and microwave video lecture series in the past few episodes. And in this episode, we are going to discuss about the alternator. It's one of a microwave passive device. So let us see what is alternator and how it is useful for the microwave communication that and all we can see in this episode. Come, let's dive into the topic. So, what problem do alternators solve? That is a very, very important thing because as we are discussing all the topics in the design thinking based, the challenges are microwave signals can overwhelm sensitive equipment, just like loud music hurts your ears, strong signal damage devices. So, volume control, equipment protection, and signal quality, these are all the problems actually the alternator. This is some real world analogy. Such kind of a problem in a microwave communication, the alternators is addressed. So coming to the defined part, why controls signal strength? This is too strong and overload damage equipment, and then just right perfect signal travel, too weak signal, too faint to use. So this is why we require the control, the signal strength is required. So how can we reduce the signal strength? That means the valve concept. You just imagine the alternates work like valve. It's a control flow with precision. T configuration, pi network design, bridged T topology. These are all the valve design uh, concepts. Here, the input signal, that is a full strength, and the control valve, that is a reduced power. Then output signal is a perfect level. Here, come to the prototype. So, what does an alternator look like? It's like a resistor network. That is a component absorbs signal energy like a sponge soaks water, and a compact design. That is a small device with precision engineering inside. Then energy absorptions reduce signal flow downstream safely. So this is like the alternator look likes in physically. So types of alternator simplified. So here fixed alternator and another one is a variable alternator. As we already know in the reflex collision oscillator in a laboratory, we have discussed about the variable alternator. This is the one of the block which comes under the reflex collision oscillator block diagram. So variable alternator in the name itself we have it's a variable. That's a so that we can vary the values of the alternation, and another one is a fixed. So here itself also there's a fixed value alternation. So in the fixed alternator, always reduce signal by same amount, like a fixed size hole in a pipe. Then variable alternator adjust signal reduction, change alternation and demand. So fixed, variable, and step. So here, fixed means that is a constant reduction. Variable means flexible control, and step means preset levels. So how alternators work in microwave circuits? So first signal enters, full power input, power reduced, energy absorbed, then shape preserved, no distortion, then impedance matched, that is clean output, like dimming the light without changing its color. The signal stays pure just in the input section, so it will stay in the line. So when come to the conclusion part, we attempted this alternator explanation by using the design thinking method. So here the empathy, understand the equipment sensitivity, and define part we specified alternation needs, and ideate part we explore resistor networks, and prototype build and test for test design for testing, and testing we variety performance we made for testing the alternator equipment. So some real world example product in microwave receivers, that is without alternator, signal overload, that is a distortion, equipment damage, and poor reception, would takes place without the alternator. But with alternator, it's perfect signal level and crystal clear. I mean, a message will be there, and protection, protected devices, and reliable performance. So alternators make microsystems work smoothly. Volume knobs, safety first, and signal clarity. So here it is a mind map where microwave alternator. We have discussed core purpose and design thinking process, types of alternators, and operation principles and real world examples we discussed. Thank you.